Welcome everyone to the Vancouver Power BI to Modern Excel user group meetup for Thursday, May 7th. Today we've got my good friend Mark Proctor who's going to be here for his second go around on the podcast here. I am looking forward to seeing what Mark's going to talk about, because I understand he's going to be talking about nothing. So that will be really interesting. So before we get into that though, I just want to go through and do our normal here. So I want a big thanks to the sponsors, SkillWave Training being my training company that trains you on how to be awesome in Excel and Power BI, is the title sponsor for the session. Excel Guru, the creator and distributor of Monkey Tools, my add-in which can help you build better Excel solutions, is also a sponsor of the session as well. Our next meetups, just a quick note on this, that there will be no meetup for the Power BI meetup next week, or sorry, not next week, the week after, which we normally do. And that is because I will be in the UK for the Global Excel Summit. So we're actually going to cancel this one, push this one off. But our next Excel track, we've got John Peltier who's going to be coming back. He's going to be talking some more about dynamic charts and dynamic arrays. So looking forward to that. And that will be followed up by our next Power BI meetup, which is coming on June 18th. Joseph Yates will be returning. He's going to be talking about reusable DAX patterns, calculation groups, and user functions. So this is going to be great stuff as well. I know that's an area that I need to spend some time looking into a little bit deeper as well. So a couple of great speakers coming up. Don't forget to RSVP to those. Reminder, if you're not familiar with Monkey Tools, we have a free course on how to use Monkey Tools at SkillWave, completely free. Teaches you all of the great features in Monkey Tools that come in the community version, that is a no-cost version, as well as what is available in the pro version and how to use it. It's about 5.5 hours worth of material there on how to use our software. It's pretty big, so definitely worth checking out. These links, by the way, are all in the slide decks, which are already posted on the Meetup site. So if you're looking to grab one of those, you can grab them from there. One of the products I just want to call out from SkillWave, my Ask Ken Anything subscription. We just had one of these sessions yesterday. Great couple of hours we got to spend talking about basically anything. We talked about Monkey Tools. We talked about a little bit of Power BI stuff. We talked about Excel and DAX and Power Query. So lots of great things that happened there. Good conversations, an awesome crew of people that joined for these. If you're interested in having someone that you can bounce things past and whatnot, you should definitely check this out. You can find this in the SkillWave shop. The Ask Ken Anything subscription is included, by the way, in our Excel Fundamentals Academy. If you're looking to get yourself or somebody on your team boned up from a beginner to a solid intermediate level, working with pivot tables and formulas and data visualization, this is a great program. About 30 hours training and coaching, access to our Ask Ken Anything sessions, lots of good stuff in this. And this program stands alone, but if you also want to, you could move up to our Self-Service BI Academy. Oh yeah, Scott, you're right. Past acquisitions are recorded, so you can always go back. Actually, we had a question on that yesterday too. Somebody said, look, I saw you do an example, but I can't remember when it was. Can you find it for me on an example that I actually built to show concert tracking, actually from somebody who was attending concerts in a variety of different places around the world. So kind of fun stuff there. So our Self-Service BI Academy, this is my premier training product at SkillWave. It includes the Excel Fundamentals Academy, includes the Ask Ken Anything session, and it gets you into working with Power Pivot, with DAX, with Power Query, how to do dimensional modeling, as well as Power BI. Lots of great stuff in this program here, really thorough, and includes your Monkey Tools Pro subscription as well. So if you're interested, check that out too. This meetup, along with all of our meetups, is recorded and will be posted on the SkillWave YouTube channel. If you are subscribed, you get a notification before I can even tell you about it on the Meetup site. But the recordings of these are posted within 24 hours. So if you have to drop off because this Mark's going a little bit long, I don't know if that's going to happen, Mark, or not. You can always pick up the recording later on. So last thing I want to say before I turn it over to my friend is, if you would like to come and speak to our user group, we would love to have you, whether it's on Excel or Power BI or anything adjacent to the Power Stack inside Office and Microsoft technologies. We'd love to hear from you. Just get in touch with us through this forum. We'll get you on our stage. We love new speakers and are always interested in things that people have to say. So on that note, I'm going to turn the floor over to Mark Proctor. Welcome back, my friend. I am super excited to hear what you have to say about nothing.
Thank you very much. I'm looking forward to talking about nothing. So let me just share my screen and then we can, hopefully that's coming through. Just if you didn't see it earlier, I'll just paste in the link so you can get this example file. I'll try and monitor the chat, but it can be difficult to keep eyes on all the places all at the same time. So let's get straight into it. Now, there are some deep philosophical questions which mankind has been asking for a long time. What is existence? What is nothingness? And if there is existence and nothingness, does nothingness really exist? And if it does exist, when does nothingness become existence? Now, the thing is that they're deep, deep questions about life. But in the last few years, I've gone deep, deep with dynamic arrays. I've created lots of YouTube videos, we've got courses, we've got tools. And through that, you start to think about, well, there's lots of scenarios and lots of examples where we encounter blank cells. That is Excel's own version of nothingness. So what are blanks in Excel? Do they really exist? And when does a blank cease to be blank? Now, the good news is that while there might be deep philosophical life questions that I'm sure we might all have different answers on, in the world of Excel, the original developers gave us an answer about nothingness in Excel. And that's what we're looking at today. So we're going to start by looking at the value of blank, the rules of existence. We'll look at a basic scenario, and then we'll work through some examples, and we'll see how far we get. So let's start with the value of blank. Now, this session could be quite difficult because blank is a lot of things, and it's not a lot of things. There's a lot of not straight answers in terms of where we begin. But here on this sheet, I have a blank cell, a cell that contains nothing, a cell that contains an empty text string, and a cell that contains a 0. So if we say what is the value of a blank? Now, if we type equals and select a cell and press return, we get 0. So blank is equal to 0. And to some degree, we can see that because if we go equals 1 plus a blank, we still get 1. So we could from that determine that blank has a value of 0. But blanks don't just impact numbers, they also impact text. We could say alpha and we could select a blank cell. Now we've said that the blank cell is equal to 0. So if we F9 that, it comes out as 0. And then if we calculate that whole thing, it shows alpha 0. But that's just because we've forced the calculation order. If we just use alpha and a blank, in that scenario, a blank is not equal to 0. We've just calculated everything at once. And the blank is effectively equal to an empty text string. So is a blank equal to an empty text string? Well, if we check our blank and check, is it equal to an empty text string? Yes, it is. And is a blank equal to 0? Yes, it is. But is an empty text string equal to 0? No, it's not. So what value a blank is and what it kind of takes on and how it works kind of depends on the context in which we use it. Now, there is a really useful function inside Excel, isBlank. We're going to be using isBlank a lot. So isBlank, we can select our single cell that comes across because yes, our blank cell is blank. Let's drag that across. As we might expect, an empty text string is not blank and 0 is not blank. Now, what about count blank? We've got isBlank and we've got count blank. You'd expect, well, not count A, count blank, you'd expect that they would give us the same results. So count blank. Yes, a blank is blank. That gives us 1. Unfortunately, a text string in count blank is also blank, but a 0 is not. So we have isBlank, where it considers only a cell that contains no value, but count blank, confusingly, counts blanks and also non-blanks. I should have a little tooltip here that's come up, which it has not, but that's okay. So we just clear the formatting from this. So count blanks counts blanks and not blanks, which is quite confusing. But it's also quite common when we think about functions like text join. This equals text join. It even has, if I put a delimiter in there, it asks us, do we want to ignore empty? Now, what's empty? Is empty the same as blank? Well, let's put that as true. So we can ignore empty cells. Let's then select our values. And when we calculate that, it just returns 0. Because from a text join perspective, blank and an empty text string are both deemed to be blank. So what is the value of a blank? Well, it could be 0. It could be an empty text string. If we're counting it, it's both. If we're checking for is it blank, it's only a blank cell. So it gets quite confusing, even in Excel, just by looking at the values we've got about what actually is a blank. Now, there are some rules of existence. At what point does blank cease to be? So there are 2 rules. The first rule is when there is direct calculation on a value, a blank is converted to a 0 or an empty text string, depending on context. So, for example, in here, if we just use equals average, and we average our 3 cells, I should say the first value is 1, the second value is blank, and then the third value is 1. So, in that scenario, how does average treat a blank value? Well, it just ignores blank values, which is probably what we would expect given our knowledge of Excel. But what happens if we perform a direct calculation on those values? Now, actually, before we go into that, it's worth saying that if we select those cells and press F9, Excel clearly shows us that the values are 1, 0, and 1, which if we calculate that would give us 0.67 as a value. But again, that's just because we've forced the calculation order. So if we're dealing with blanks and we press F9 to calculate that, it will always display a blank as 0. But that blank is not 0. Now, what happens if we perform a direct calculation on our values? So we'll use average again. We're going to select our numbers, and this time we're going to multiply by 1. Any number multiplied by itself brings back itself. So 1 multiplied by 1 should be 1. But what happens with a blank multiplied by 1? Well, here we're performing a direct calculation. Therefore, the blank will be converted to a 0 or an empty text string. So as we might expect, we get 0.67. And that's because our value here, our blank, has been converted to a 0. Now, what happens if we perform the direct calculation of a blank with another blank? So what happens in that scenario? So if we take our values and we multiply them by our same values, what's going to happen there? Well, we're going to get kind of the broadcasting principles. So the first array, we're going to have 1 times 1. We'll then have blank times blank, and then 1 times 1. So blank multiplied by blank, we're still performing a direct calculation, and that still gives us the same result. So what's happening inside these values is that we still have direct calculation on a blank value. Therefore, it is converted to a 0 or an empty text string. Now that's rule number 1. Where there is direct calculation on a value, blanks are converted to 0 or an empty text string. Rule number 2. When a blank is returned to the grid, it automatically returns as 0. So if we simply select that cell there, type equals, select the blank, we can see that that returned as 0. So we have our 2 rules, that a blank ceases to be blank where there's direct calculation on the value, or when the value is returned to the grid. Now, it's also worth considering about the differences between ranges and arrays. Are blanks different in ranges to how they're displayed in an array? So basically, we're trying to find out, in these cells here, is blank, is that an attribute of the cell, or is that an attribute of the value in the cell? Because if it's an attribute of the cell, when we convert that range to an array, it means that we potentially have caused calculation on this range and converted it to 0. So let's understand the differences between ranges and arrays and whether that impacts how Excel thinks about a blank value. So if we just type equals and select our cells, all that's going to do is give us those cells back. And now let's wrap that in is blank. We now get the true and false values. So we can see that 1 is false, that blank there comes across as true. Now, if we take this reference here and we use equals is ref, it's going to tell us that this is true. So this is a range reference. The values that we're looking at here are a range. But what happens if it becomes an array? So let's try an array calculation equals vstack. And we're going to stack the 1, the blank, and the 1. So when we stack the 1, the blank, and the 1, if we do that, what happens to our values? So equals is ref. In that scenario, Excel is going to say that this, so when we use vstack, this is not a range reference anymore. This is an array. That means it doesn't have any visible presence. The vstack of these cells just creates an array in memory. And this is not a range. So what happens if we is blank on this array? So we know that vstack is going to return an array and not a range. So what happens when we is blank on here? It still returns true. So that means that blank or nothingness is not an attribute of the cell. It's an attribute of the value itself. Now that's quite a useful thing to know. We're going to use that concept later on when we look at some examples. So let's take a look at another example. Here, everything is just in the same position. What happens if we sort? So let's sort these values. Now, as you'd expect, we now get 1, 1, and 0. So our values are now sorted. We know that if we sort, it can't be a range because those values are not in the same order. So those values have changed order. Therefore, it's definitely not a range. It is an array. And if we is blank that, we can definitely see that that last value is blank. So it was there. It was then sorted to the bottom and it retains its blank attributes. So this is really good when we think about how we handle arrays. Now let's take a look at a simple example to see how this flows through. And our goal here is simply to filter by the items that are medium, and then just to see what happens. Okay, so we're going to start with a filter function equals filter. We're going to filter our array where our size is equal to medium. When we calculate that and commit that value, we get alpha, delta, and hotel. And these values, these are the blanks, but they are the blanks, and they are in, but they've been converted to zeros. Now let's just add some more complexity onto this. Let's add a sort, and let's sort by our in ascending order, or on the first column in descending order. So now our zeros are at the top. That means that whatever values we had here, they definitely aren't in the same order as they were. But these zeros, are they zero because we have performed as per rule 1? Are they zero because we have performed a calculation and therefore they've been converted to zero? Or are they zero because they are blanks that have been returned to the grid? So let's take a look at this as an example. We're going to use the let function, and we're going to call our previous result calc. Now I should say, let me just return calc here. I should say that we are going to use a lot of array-based calculations today. So if you're used to kind of a single cell world, let me just give you a quick example here. So if we have a range 1, 2, 3, 4 an array, and then let's repeat that range over here, that when we perform a calculation on these values, so for example, if I select that range there and multiply it by that range there, what happens is that Excel undertakes a positional or a relative calculation. Therefore, so we've got J6 and K7 and M6 and N7. So 1 will be multiplied by 1, 2 will be multiplied by 2, 3 by 3, 4 by 4. So when we calculate that, they're the results that we get. So just be aware that anytime we perform these array calculations where we have rows and columns, what's happening is that the calculation is being performed based on the relative position of those items. So let's try that. We've got our calculation, which gives our values here. Now let's find out whether those values are blank. So is blank, opening bracket. We're going to use the is blank function. And if we want to find out whether each of our cells in our calc is blank, and then we're going to return our is blank value. And as you can see, these two items return true. That means that those values at the point that we calculate them, even after we've performed our filter, after we've performed our sort, those values are still blank. So our values here have not applied rule 1. Rule 1 is when we perform direct calculation. There is no direct calculation on those values. So we're facing scenario 2. This is where 0 is returned to the grid because the value has been returned to the grid. So let's continue with our calculation. And we're going to say that our result is going to be if our is blank. So we've got our array, 3 by 3 grid. If that is blank, if that returns true, then instead we could force an empty text string, or we could return our calc value. So again, it's working cell by cell. If each of those corresponding arrays, if it says true, then it will return an empty text string. If not, it will return the original value from that cell. I didn't return the result. So as you can see, we've now forced Excel to treat what were our original blank values. They now look like blank values. They're not, they contain empty text strings, unless of course you use count blank or text join, in which case they are still deemed to be blank. But in all honesty, these cells are not, they contain an empty text string. So that is our basic scenario. If we can understand whether we have implemented rule 1 or rule 2, it then means that we can kind of treat those values however we want to. For example, in here, we might not want an empty text string. Maybe they're empty because they're still to be determined. The value definitely isn't 0, in which case we can force that blank to be something like TBD, to be determined. And therefore, we know that the cells aren't blank if someone's still got to do some work on them. So that is our basic concept when working with Excel about when does a blank cease to be blank. Let's now look at an example to see how we can remove blank rows. Now, I posted a video on this a while ago. I'll tell you, the comments were alive with people being angry about the fact that we could use a function to remove blank rows. People were there going, why don't you just use the shortcuts, whatever they happen to be? But the truth is that if we've got a table, for example, and we're copying and pasting values into this table, then we probably want the blanks to be removed automatically. So there is definitely a use case for a formula. Yes, you might use Power Query, and if we get time, we'll look at that at the end. But if we're just copying and pasting values into a table, or someone's filling out a table and there are blank rows in there, there are definitely scenarios where we would want to update that automatically, so therefore we don't have to perform those same shortcuts and those same methods of removing the rows over and over again. So let's take a look. Our goal, therefore, is that we want to just get those values, and we don't want any of these completely blank rows. Now, as I was saying here, I have got some cells here. This cell is already blank. This cell already contains an empty text string. So let's start building out our solution. We're going to start with the let function. If you haven't used let before, let allows us to create names so we can assign values to those names. And it makes it easier for us to create calculations. The first name I'm going to create is array. And we're just going to select our table of values. We have our array, and my table is called example 1. Let's now carry out the check to find out which cells in here are actually blank. So my steps called is blank. I'll use the isBlank function. My value is going to be my array. And now let's output that. And you can see there we've got my full blank row. There we've got another full blank row. We've got two other blanks. The 0 there is not, and my empty text string there is not. Therefore, we know we want to remove these two rows. We've now got a true or false. Now we've got a function that will tell us whether, let me just show you this over here. If we use the AND function, and tells us whether all of the items are true or false. So you can see here, that tells us, based on that entire row, that all of those cells are true. And we only get an AND where, or we only get true, where all of the values are true. So let's add this into our calculation. And we're going to use the, we're going to call this, we're going to check the row is blank. We're going to use a by row function. The values that we want to use is our is blank. This is just our array of trues and falses. And for that, we want to return the, is blank, and we want to use the AND function. Now, we're not going into eta reduction on lambdas today, but we can use the AND function that will then work on the entire row of values. And that now tells us we get a single value, true or false, as to whether that row is blank. So next, let's determine what rows we want to keep. So keep rows. We're going to filter our array based on where we have our where our row is blank. If I use row blank, that was our single column of trues and falses, but we need to flip the signage on those. So I'm going to choose not. That will flip the signage. And when we return that, we then get our array with all of those rows removed. But we've got a problem. These two values here were originally blank, and they're now showing zeros. Even this medium here, that's now showing 0. But the original value wasn't 0. It was blank. Therefore, we may look at this and think that this value should be 0. But it's not. As I said, it could be a value that's missing, a value to be determined. Maybe we don't want to treat this as a 0. So we come back to our rules of existence. Have we performed any direct calculation on any blank values? We haven't. So why is it 0? Because it's a blank value that has been returned to the grid. Which means we can add additional steps into our results. So these values are still blank within the calculation. It's only when we display them that they suddenly become 0. So let's find out whether something is still blank. We're going to use the is blank. Now there are other ways we could do this. This is just kind of trying to think through the solution. We're going to use is blank on our keep rows. That will give us another true or false. And we should see, again, these values are still blank. So we can then result is going to be the if is blank. That means, if still blank. If that value is still blank, what value do we want to give as an alternative value? Let's give it an empty text string. Otherwise, we return keep rows. And then we're going to return our result. There we go. So we've now filtered our values, and we can see which of those cells originally contained blank values. And if we get more data, let's add these up into our table. Those cells or those rows which are blank are automatically removed from our results. Now, here we've got a function. And if this is the thing you do on a regular basis, you can easily turn this into a Lambda custom function. So I've got my own library of Lambda functions. You can see them here, which I've saved. And if I search for blank, you can see that I have one which is called remove blanks. If I click insert, that would then add that into the workbook. You've already got this function inside the start workbook. So if I had this custom function, which I've created, effects remove blanks, I could simply select my array. We've got some optional arguments in here that we're not going to worry about today. We can commit that and calculate, and that gives us exactly the same value. So we don't have to stick with this kind of complex calculation. We could turn that into our own custom function that therefore we can apply quite quickly. So that's how we can remove blank rows. And as you saw, if we get new items into our table, it automatically updates. There's actually two elements here. We've got the concept of removing things that we don't want. But how about adding things that we do want? So in this scenario, what we're looking at is how can we insert the appearance of a blank row? What we want to do is to sort this data. So we end up with alpha, 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 and alpha. We have those at the top. Then we're going to have a space, and then Bravo, Bravo, and the two Bravos, then another space, a row, and then our Charlie items. So what we'll have is Alpha, Bravo, and Charlie with their blank row between each item, so we can easily see how they are grouped. That is our goal. Now, believe it or not, inserting a blank is significantly harder than, or inserting the appearance of a blank in the middle of an array is significantly harder than removing them. And we're going to build up our example here. Now, before we start, I'm just going to type equals, and we're just going to sort our item column. This is going to become useful later because this is the order that we will be sorting things in. So we're going to talk through this. I'm just going to add that there to make that easy for us to see. Now let's build out our calculation. Equals, use the let function again. And we're going to use our array is going to be our example to table. Now, first thing we want to do, we've got our array. We then want to say what column do we want to sort that by? Call that the sort by array. And we want to sort by the item column. So just as an example, if we get a result, let's carry on. This is sorted. Array is the sort by of the array based on the sort by array. And then we can return that as the sorted array. I've typed something incorrectly. Array, sort by array, sorted. Got a typo, so I'll sort by. There we go. So we've now sorted our values into the same order that we have. What we now want to do is so we really need, because effectively we want to look down this first column and be like, hey, whenever the first column changes, that's when we know that we need to insert a blank row. Therefore, we are going to take our, we're also then going to sort our sort by array. So sorted, sort by array. For that, we're going to sort our sort by array. That's simple. That's just so that we can get a single column of values. So that just gives us a single column. So we've got our sorted array, which is all the values, and our sorted sort by array is just the single column for our items. Now, our goal here, what we want to do, let me go back to our sorted array. The overarching principle here is what we're going to do is we're going to have our values here. We're effectively going to create an array. So we need, actually I need two. We're going to create an array that contains two blank rows. And that's because we have a blank row between Alpha and Bravo and a blank row between Bravo and Charlie. So at the top, what we want to do is to create an array that has all these blank rows and the blank rows below. And then we're going to use the index numbers to determine, when we sort them based on those index numbers, what order those values come in. So for example, if we had our index numbers there, we would say that we want our first blank row to be 5 and our second blank row to be 9. Therefore, when we sort these, if we were to, we'd get all of those. It would then give us, we'd get all of those. We'd then get our first blank row. We'd then get the Bravos, get the next blank row, we get the Charlies. That's the calculation that we're trying to perform. We just undo all that. That was just to explain how the calculation is going to work. Therefore, we need to think about position. Position is really important. And for that, we're going to create an index position. Index position is just going to be a sequence of the rows from our array. We can output that. And therefore, we just get the numbers from 1 to 12. We've now got our index position. The other array that we really want is to know whether our value is the same as the value above. Now, as I've been creating these Lambda functions, I found out that checking whether something is the same as the row above is actually quite a common calculation. I'm going to call this different to above. So different to above, we're going to use the drop function. We're going to do our drop on our sorts, on our sorted sort by array. And we want to drop the first row. And we want to check whether that is not equal to the drop of our sorted sort by array. And we want to drop the last row. Now, that may not make a lot of sense. Just think about the logic afterwards. And what we end up with, if we adjust this by one row, is there you can see Bravo is not the same as Alpha, so it returns true. Bravo is not the same as Charlie, Therefore, it returns true. Now, because we are comparing it to the item above, that means we don't have a first value. So what we are going to do is to vstack a false on the start of that. That will then give us an array of true and false values. The false and true as to whether it is the same as the value before. We can now use this filter on our index numbers. So remember, we had our index positions, which were the numbers 1 to 12. We're then going to use our index position. I'm going to call this keep position index. And our keep position index is going to filter the index position. And I want to filter it where the value is different to above. Let's now output this. Get our keep index. And you see we get numbers 5 and 9. So rows 1, 2, 3, 4, 5. That's the place there. And 9, that would be the value there. So our 5th item and our 9th item are where we will need to insert our blank rows. We now need to create 2 blank rows. To do this, we're going to use, there's a few methods we could use. One that I quite like is using the sequence function, believe it or not. So we're going to call it create blank. Create blanks. And we're going to start with a sequence. We want a sequence that's going to have the number of rows from our keep position index. So that means that our position at the moment index had 2 rows for the numbers 5 and the number 9. Now we know that our data here has only got 3 columns. So we want an index of, that will give us 2 rows, 3 columns. Let's return create blanks. Therefore, we now have, because we had 2 rows, the numbers 1 to 6 that are the exact size that we want for our blank rows at the top. Means that then we can say that if, now if is going to check whether so if works on true and false values, but any number or any non-zero number is deemed to be true. Our sequence has created all non-zero numbers. So we can say that if sequence, so if that's true, if that's a non-zero number, then return an empty text string. So we now have 2 rows that appear to be empty. We've now got all the pieces that we need. We now just have to stack these bits together. So we're going to call this full array. Our full array is going to be our vstack of create blanks and also our original, our sorted array. Let's return that. Here is our full array. So there's all of our values. We have the blank rows at the top. And we have our values below that. We also have our full index, which is going to be the vstack of our keep position index, and also the position index or index position. And when we return that, we get 5, 9, 1, 2, 3, 4, 5 to 12. So they are the positions, which means that finally we can get our result of sort by. We want to sort our full array based on our full index. And our result is a name error, full index rather than fill, which means we now have alpha with a blank row, Bravo, blank row, and Charlie. And if we get more data, then that will automatically add a blank row in for each of those items. Now, as I said, I've created a lot of Lambda functions. So how can we, search for insert, I've got insert values between items. So that is the function that I could insert. That's already in this workbook. So if you've got the example file, you've already got this, equals fx, insert values between items. Here is, now this won't work initially. I'll explain why. there is my array, and then my compare array. It's going to be the items. This initially won't work because my values aren't in order. So it's inserted blanks between every single unique or every single item. So Alpha, Bravo, Charlie. And then when they're grouped together, it returns those two. But you can just use our sort. So let's use the sort on our table, column 1. And we want our sort by is going to be on column 2. This isn't the way I did it in my example. I knew that wouldn't work. Let me do it the way I did it in my original example. So we want to sort by, got our original table there, to sort that by the example 2. And then our compare array is going to be the sort of our item. So now we've got a Lambda function that will, however whatever items we get, will now automatically insert those rows into those areas. I can see someone in the chat. So someone mentioned about show blanks as in the pivot table. That gives you exactly the same scenario as that. But often it doesn't just have to be a pivot table. It can be inserted into anything you like. And again, if you don't want to use a blank, these functions here, if you don't want to use a blank, we could use some dashes or something like that. So you've got other options. I suspect the blank is probably the most common thing that we might want to add just to create spacing to help readers understand these values. I've got just enough time for another example. I think John Peltier is still here in the room. I need to credit John with a lot of this knowledge, which I'm about to apply. So what I've got here is a chart. As you'll notice, I've got my data here. So I've got my years, 2024 to 2026, quarters, and I've got some values. And now I've got my chart, and my chart has got, or I've got the values that I've then linked to each of those columns. Because this has returned values to the grid, it means that it is using zeros. And so therefore those values are coming all the way down to the bottom to display these as zeros, but also the grouping at the bottom that we've got here. You can see we've got Q1 2024, Q2 2024. We've got that year repeated for each item, when it would be nice if they were grouped together. But here we've got a table. Hopefully our table is in first normal form. There's no blank rows in our data. There's no missing items in our data. If we're cleaning data in Power Query and sending it to Excel, this is the structure that we would want. But for our chart, this isn't the structure that we want. Instead, what we want is to get blank values for each of these items. And when we do that, it then creates the nesting of our values within the year structure. So let's start here with a nice simple one. If you've used charts before, you know that the NA function or the NA value doesn't render on a chart. Here we've got a 0, so it comes down and renders a 0. Now blanks, as we know, if it were a blank, if I can just show that, if I had a blank, that wouldn't render on the chart. But here we've got a formula. Now, why is this 0? Is it 0 because we've performed some kind of calculation on it? No, it's 0 because it's been returned to the grid. So we can use if that or if is blank. So if those values are blank, if that's true, we want to return the NA function. Otherwise, we want to return the original value. There we go. So we've now forced NA into our workings, which means that it now doesn't render Q3 and Q4. But what about our year values? how are we going to, we want to force blank rows or blank values. So we end up with 2024 as the first item. Then the next 3 we want to be blank or empty text strings. 2025, the next 3 are empty. 2026, the next 3 are empty. Well, we've already seen all of these techniques already. So we're going to use let, opening bracket. Our array is going to be our year column. We want to check if the value is the same as above. And we're going to use the same method. So we're going to VStack. This time we're going to VStack a false with the drop of the array, comma, drop the first row. And then we want to check whether that is equal to the drop of the array minus the first row. So that is the same technique as we used before to get the true and false results. Let's just return that. This might break our chart. I'm missing some arguments somewhere. I've got too many brackets. So now we're saying false, 2024. We want to keep 2024. We want to keep the first 2025. We want to keep the first 2026. The other values are the values that we want to return to strings. And we can use the same technique as we used before. Result, where if same as above, the value if true. So if that's true, we want to return empty text string. Otherwise, we want to return our array. And then we want to return our result. Now, here's the thing. Take a look at this chart axis at the bottom. When we calculate that, we now get those nested under each year. So we get 2024, 2025, and 2026. And if we add new values into here, it expands automatically, and we now get 2027. And if we end up with more or less values, it groups those accordingly. So that is how we can get these blank values into charts. If they are the values, we can use the NA function to force a value. If they're part of the labels and we want to group them, then we can use an empty text string. Now, it won't surprise you. It won't surprise you to know that I've got a Lambda function for this. FX replace repeat values. And this is already in your workbook, or it should be. So FX replace repeat values equals FX replace repeat values. Got my array, my positions array. I think I need a 1 in there. And therefore, I now have a Lambda function that replaces repeat values automatically. So again, we can take those more complex calculations and turn them into functions that are reusable. I'll just show you one more example. I've got 6 minutes. 6 minutes. Let's see if we can get this. So Power Query is different to Excel. Power Query is very explicit about blank values. Here we have a table that contains blank values. We've got blank rows and blank columns. And just as we have some custom functions for Lambda, we also have some custom functions for Power Query. I have my remove null columns function, and this is already in your workbook. It should already be in your workbook. So we're going to use that in a moment's time. So let's just load this into Power Query. Now, removing completely blank rows is easy because we can just go remove rows, remove blank rows. That doesn't hard code specific column names by default. Therefore, we can easily remove blank rows. Now, to remove blank columns, in theory, we could transpose, remove blank rows, and then transpose back. But if you've got a lot of data, the refresh time on that is huge. So instead, we can use we can use another technique. We can use Table.Profile. The Table.Profile function on our previous step. that function is going to tell us how many rows we have and how many of them are null. If I can zoom in on this. So we have the count, 9 rows, and how many of those rows in each column. So in column 1, all of those rows are null. Now, unfortunately, there is a little bug in Power Query that means we can't just remove the rows where count equals null count. I don't know why, but if we were to filter this, just equal 9. Let me do it over here instead. So if I filter the null rows where equals 9, it says null count. So we can't say I want it where null count equals count. For some reason, it can't find null count, and I've got no idea why. But what we can do instead is hit add column, custom column, and we want to check where count is equal to null count. Or if we say where it's not equal to null count, and then these are the rows that we want to keep. Let's keep those. So the ones that are true are the ones that have actual values. They're not completely blank. We want to keep the trues. In the first column, we have our column name. So we can declare that column name. That then gets us a list of the column names that contain. So we've now got a list of the columns that don't have all null values. And then finally, we can reference our, I think it was remove blank rows. Let's reference removed blank. Give me there. Hash. Remove blank rows. That's got our table back. Then if we, using that, we can simply select the columns that we want, or any columns. Choose columns, or remove columns, remove other columns. You get a list. And that list we can replace with our step called filtered rows. We would normally change these column names. Change that to hash filtered rows. And therefore, we've now got from our source, which contains blank rows and blank columns, all the way to a data set that's removed the completely blank rows and the completely blank columns. And as I said, we've got another custom function here, which is in your workbook. So if you want to avoid all of that stuff with Table.Profile, I'll click on FX, use FX, remove blank columns. That's our custom function. Calculate on that, and it does that automatically. So all the logic is in our custom function. So we can remove them simply by removing the blank rows, and then for the columns, we remove the null columns. Just close and load that back to Excel. I'll do a connection only. And that brings us to the end of our exploration. That brings us to the end of our exploration of blank values. We've seen that blanks can be treated in lots of different ways in Excel. They are equal to empty text strings. They're equal to blanks. They're equal to zeros. We've seen at what point a blank ceases to be that value. And therefore, we can, once we know when that happens, we can then start to manipulate it. And we saw that actually a blank value is not associated with a cell, but the value itself. And that propagates through all of our formulas. And it's, or provided we don't provide any direct calculation on it, and it's only when it's returned to the grid that we then get the 0. We then saw our basic scenario where we applied that. And after that, we looked at some examples about how we remove blank rows, how we add the appearance of blank rows, purely a formatting trick, how we use blanks in charts, and how we use blanks in Power Query. So all that's left to say is, so I am Mark Proctor. We've got a free course. If anyone's interested, Modern Excel Formulas, there's a QR code there. Yeah, it's a free course. It lasts about an hour. It goes through some of these techniques about how we use let and how we work with that broadcasting principle of how we work with arrays. So if anyone's interested in that, there's a QR code there so you can access that free course. So Scott, if Scott says array formula still make my head swim, that's the place. to head over to. Hope it'll start to explain how these things work. Shirley Wilmer said, "How do you get the workbook?" I'll drop that. I'll drop that link into the chat after this call. I will update. I will save into that same link the workbook that I've just been working on. I didn't put the final version in because there was a good chance that I wasn't going to create the answer in the same way. So the example file that will be there in about half an hour will have this file and also the start file. So thank you very much.
Mark,
Again, back to you.
No, not yet. I want you to, can you go back into your Power Query example where you did your Table.Profile?
Yes.
Cool. All right, let's duplicate it so that and then we can delete the steps, because I want to look at that Table.Profile where you went to filter your column that ended up returning the error.
Yes.
So let's just go back to that. So right here, right, you tried to filter your null count to number 9 and it failed. Change the data type to a whole number first.
So if you do that, any step before you do that, we'll make that work.
Yeah, the issue is this at any data type, and you can't filter for a value when it's an any. As soon as you switch that out to a whole number, you can now filter to number 9 and it will work just fine.
Okay. Yes, that could be right. Yeah.
No, 100% it is. Just test it.
Yes.
And I ran into this the other day with something, is that trying to do filters on untyped columns causes problems sometimes, not always, but sometimes. So this one, it definitely appears to do so. So there's your answer for that one. So, but dude, awesome. I love this. A fantastic session. Great stuff. I honestly can't believe you could talk about nothing for a full hour, but well done.
But thank you very much. It's quite a skill.
And now you get to go back and you talk to your kids, right? What did you do today? Nothing. Which is usually what they tell you, right? So
yes, that is exactly what they tell me.
Exactly. There you go. Thanks everyone for coming today. Mark, a fantastic presentation. Really appreciate having you back again to do this kind of stuff. I'm very much looking forward to seeing you in London in a week and a half. And for everybody else, don't forget that we've got a couple of great meetups. John Peltier is going to be coming back and talking about some dynamic charting techniques with dynamic arrays. See, now he's going to have to go and do more work because you went and stole some of his thunder, Mark.
I know.
You put him to work. It's just cruel. At least Joseph doesn't have that issue with this.
He's easily got enough skills to outdo me. There's no problem there.
Yeah, well, I'm sure he'll bring us something fantastic because he always does. Don't forget also that Joseph Yates will be back in for our next the Power BI meetup, which is not going to be in a couple of weeks, but is going to be a month after that. And he's going to be talking about calculation groups. So that should be great stuff as well. So on that note, we're going to shut it down for today. Thanks again, everyone, for coming. The recording will be up in the next 24 hours for it. And I know Mark's going to be updating his example file. We will see you all soon. So thanks again, bud. Really appreciate it.